A few years ago, the United States tried to do something unprecedented, freeze an entire country's chip industry in place. The weapon was a single machine, the Extreme Ultraviolet Lithography Tool, or EUV, the one device on Earth you need to print the most advanced chips, sold by just one company, ASML. Cut China off from EUV, the thinking went, and you cap it at older, slower chips forever. 4 years later, China is making 7-nanometer chips, developing 5, and has reportedly switched on its own experimental EUV machine in a Shenzhen lab. So did the most aggressive tech sanctions in history fail? Or is China paying a hidden price for every chip it makes? Let's get into it. First, why one machine matters this much. To carve the tiniest features onto a chip, you need light with an incredibly short wavelength. Below about 7 nanometers, the only practical tool is EUV, and ASML in the Netherlands is the only company that makes it. Washington's export controls block EUV from going to China at all. The goal was simple. Without EUV, China stays stuck at mature nodes. But China found a loophole. Its leading foundry, SMIC, already owned older machines, deep ultraviolet tools, or DUV, the previous generation, bought before the rules tightened. By running a wafer through those machines several times, a trick called multi-patterning, SMEC can fake a finer node. That's how Huawei shocked everyone in 2023 with a 7-nanometer phone chip, made entirely in China. So the ban didn't stop production. But what did it cost? Here's the part the headlines skip. Multi-patterning works, but it's brutal. To draw what EUV does in one clean pass, DUV has to expose the same wafer over and over, with perfect alignment each time. Every extra pass adds cost, adds defects, and slows everything down. The result is yield, the share of chips that come out working. That's reportedly around 20% for these advanced nodes. Think about that. For every 5 chips SMIC tries to make, 4 are scrap. TSMC, by comparison, runs mature yields in the 90-plus range. So China can make a 7 or 5 nanometer chip, but each one costs far more in far smaller volume than the same chip from Taiwan. And it's still roughly 8 years behind the leading edge, while TSMC ships 2 nanometer today. This is the honest picture. The sanctions did not build a wall, but they did pour sand in the gears. China is moving, just slowly, expensively, and with a lot of waste. The loophole is real. It is not a substitute for the machine. Which raises the obvious question, if it's this painful, why pour in the billions at all? One word, independence, especially in AI. When the US also blocked NVIDIA's top accelerators from China, it didn't just threaten phones, it threatened China's entire AI ambition. So Huawei built its own answer. The Ascend line of AI accelerators, the domestic stand-in for the chips it can no longer buy. And SMIC is Huawei's exclusive foundry for them. The plan isn't to beat NVIDIA on a single chip. It's to make enough good enough chips at national scale that China's AI build-out never depends on a foreign supplier again. Reports point to a target of more than 1 million high-end dies in 2026, and Huawei is said to have stockpiled around 90 of those DUV machines, a $5 to $7 billion buffer before the controls fully bit. It's a bet that volume and self-reliance matter more than efficiency. Expensive chips you control beat cheap chips someone else can cut off overnight. Whether that bet is wise or wasteful depends on what you think the next decade looks like. But it is, unmistakably, a national decision, not a commercial one. But the loophole has a ceiling. To truly break free, China has to build the one thing it's banned from, its own EUV machine. And this is where it gets genuinely audacious. Inside a high-security lab in Shenzhen, China has reportedly built an EUV tool that can already generate EUV light, though it hasn't printed a working chip yet. Crucially, it uses different physics than ASML, a method called laser-induced discharge plasma, instead of ASML's laser-produced plasma, a deliberate end run around the patents and know-how locked up in the West. And the scale of the effort is staggering. Huawei, a state-backed firm called SiCarrier, and institutes across the country, Harbin for the light source, Changchun for the optics, SMEE for integration, Over 3,000 researchers, coordinated like a national Manhattan project for lithography. The timeline is the catch. Trial machines are being talked about now, but realistic mass production is more like 2028 to 2030, and plenty of experts think even that is optimistic. Remember, ASML took decades and an entire global supply chain to make EUV work. China is trying to compress that into a handful of years, almost entirely alone. So let's be honest in both directions, because this story gets told as pure triumph or pure failure, and it's neither. On one side, the sanctions are working. China has no EUV in production. Yields are punishing. It can't match TSMC on cost or volume. It's years behind, and its most advanced homegrown lithography tool that's actually shipping is still only 28 nanometers, generations short of where it needs to be. By the narrow goal of slowing China down, the controls clearly succeeded. But on the other side, they may be backfiring. Before the ban, China was happy to buy foreign tools and stay dependent. Now it's being forced to build every single layer itself: design, foundry, materials, and eventually the machines. A complete, parallel, sanction-proof supply chain. Some call it the silicon curtain. And here's the uncomfortable part for the West. A wall that's painful to climb is still a wall you eventually get over. The honest question isn't whether China is behind right now. It clearly is. It's whether the controls bought a lasting lead or just guaranteed a competitor that, one day, can't be cut off from anything. So here's the verdict, and it's a question of how you read it. Don't read China's chip program by the node number. Read it by the mobilization. Whether the homegrown EUV works in 2028 or slips to 2032, the thing that actually changed is this. China is now building the entire stack itself because it has no other choice. And that's the real contrast with the other nations chasing chips. We covered India and Japan, and both are buying their way in. India leans on Taiwan's power chip and ASML's tools. Japan's Rapidus leans on IBM and ASML. They're betting on interdependence, joining the system. China was denied that option, so it's making the opposite bet. Build everything alone, whatever it costs. And the tell is the scale. You don't fund a Manhattan Project-sized lithography effort for a single vanity chip. You fund it so you can never be at someone else's mercy again. So did the sanctions fail? Honestly, no. They genuinely slowed China down, and that was the stated goal. But they may have also done something the West could regret: turned a customer into a rival that's now building its own version of the most important machine on Earth. The chips are the story everyone watches. The machine is the story that actually matters. If you want the real engineering and geopolitics behind the chip world, who's building what, who depends on whom, and why it matters, this channel takes it apart one piece at a time. No hype, no hot takes, no taking sides, just how the silicon really gets made and who's racing to control it. We've now looked at India, Japan, and China. 3 nations, 3 completely different bets to break into chip making. Watch those next if you haven't. Subscribe and stay with it, because the map of who makes the world's chips is being redrawn right now. Thanks for watching.